Alright guys, welcome back. We're going to be solving question 86 from the second chapter of Mechanics-Statics by Meriam, and we have 5 forces that are applied to the beam trolley as shown. We need to determine the coordinates of the point on the y-axis through which the standalone resultant R must pass. And we know that the F is 5 kilonewton. We have theta 30 degrees. So we solved a couple of questions in the previous videos that basically is replacing all of the forces with one single force that represents all of the forces, and also it makes the same moment about one single point. So now we have 5 forces. Obviously they have a resultant, and we need to replace that with one single force that gonna passes through this y-axis, and that has to make the same moment about O. So let's start the resultant first of all. So our R is the sum of all forces in all directions, and we can see that we have X and Y defined in the question. This is our X and this is our Y. So let's start with the X, see what we have. So we have 0.6, 0.8, so 0.6, 0.8, they're both positive. And we have these two which are negative because they are in the opposite direction of x-axis, and also we have the x component of F, which will be this, and this will be the Y. So since we know this angle is 30 degrees, our theta is given in the question. Our F is also 5 kilonewton. So 5 sine of theta is going to be our x component, and it will be positive too. So 5 sine of 30, and that's going to be our y component. Let's move on to j, or the y component. So there's only one force in y, which is the y component of F, and that's going to be 5 cosine of 30 degrees j, and everything is in kilonewton. So let's just figure out our resultant. So 0.6 plus 0.8, negative 7, plus sine of 30 is 0.5, so 2.5. So this is going to be negative 3.1 I, and 5 cosine of 30 is going to be the j, or our y component, 4.33. We kept everything in 3 significant figures. Kilonewton, that's our R, and we can see that our R has a negative x component and positive y component. So our R is in this direction in this question. So now we have to figure out the moment to see if the moment about O is clockwise or counterclockwise, and based on that we can locate our R either below x-axis or above, because these two are going to make the two different direction of the moment. The one below is going to be counterclockwise, clockwise, and the one above that is going to make it counterclockwise. So let's figure out the overall moment about point O. So we're looking for moment about O, and we have our sign convention counterclockwise positive. Okay, so let's start with the 4 kilonewton on top left corner. So we can see that the moment first of all is going to be counterclockwise, so positive. So our force is 4, and the distance, we're looking for the vertical distance from O to the line of action, which is this distance, the distance from center of this to this top. So we are looking for this distance. We know this would be half of 280, so 140, and we know the radius of this pulley is 55, so this distance is 55 times 2, or 110 millimeters. So our distance that we're looking for is 140 plus 110, can divide by 1000 to get it in meter, since all the dimensions are in millimeters. So that's pretty much everything for the 4. 3 kilonewton also is going to be counterclockwise, so plus 3 times the distance would be, this is the line of action, so basically we have this 140 millimeters for that one, and we have the moment of this 0.6. These two are also counterclockwise, so positive 0.6 times same distance. This is the line of action, so we're gonna have again the half of this beam in here, which was 140 millimeters, and also we have point A, same direction, positive 0.8 times. We have 140 plus the diameter of the pulley, so 140 plus 110, and all divided by 1000. And since F is passing through point, or it won't make any moment, so all we need to do is just to calculate this value in here, and that's going to give us the moment. So 4 times 140 plus 110 is going to be 250, so 0.25 plus 3 times 140 plus 0.6 times 140 plus 0.8 times same thing, 0.25. Oh, I forgot to, these are all need 1000. I forgot to. All right, so that's gonna give us 1.704 kilonewton meter, and since we didn't get any negative sign, that shows that the moment is counterclock. Our sun convention was counterclockwise positive. So now we can decide that which R we need to take, either this one. So we were thinking to choose between these two options. So now that we figure out the moment is counterclockwise, we can see the bottom one is going to make a clockwise moment, and the top one is the one that's going to make a counterclockwise. So this is going to be our choice, and we can see that the Y that we're going to get has to be negative, because the line of action is going to pass through negative Y, since this is our positive Y. So now all we need to do is just to find a moment of that resultant about O. So let's just clean up the figure. So we know that the line of action of our Y is going to pass us through this. So we can resolve our R into two components, this one, and we can see that, so this will be our Ry and Rx, and this is our R. We can see that only Rx is going to make moment, and what we are trying to figure out is this distance Y. So we have Rx times Y is going to give us the same moment. So Rx is 3.1. 3.1 times Y is going to give us the moment about O, which was 1.704. So let's just calculate this. 1.704 divided by 3.1. So our Y, first of all, this is the absolute value. We know that our Y is negative based on what I explained. So the actual value is negative 0.550, and this is going to be in meter, so we can just report Y 550 millimeters, and that's what the question is asking. So the coordinates of that point is going to be, obviously the X is 0 because we are on Y axis, and we're going to go 550 millimeter along the opposite direction of Y axis. Everything was clear. Let me know if you guys have any questions. You guys take care. I'll see you in the next video. Have a good one.